Now I'll go through the test revision, and the first one involves these two matrices. This matrix has unknowns in it, this one has numbers. So to add the two matrices, you add the corresponding elements. So this is called the 1, 1 element, and that's the 1, 1 element. They add together to give 5 in that 1, 1 element. You always say row and column, row first, column second. So this one here is the 1, 2 element. You add that to the 1, 2 element to get that there, which is the 1, 2 element for the final matrix. So that's how you add. This one here is multiplying by a scalar and then subtracting. Multiplying by the scalar is easy because this is timesing by a half. You times every corresponding element by a half, and then you subtract A. When you multiply matrices, you've got to do row times column. So row 1 times column 1 will give the 1, 1 element, whereas row 1 times column 2 will give the 1, 2 element. And when we're multiplying these, you do the multiplication between elements and addition, multiplication within elements and addition between. In other words, 1 times 4 plus 3 times x. So that gives you the multiplication. You have to get the order right too. So B has to be after A. Here's B, here's A. B squared is B times B. Doing the same process. The determinant of B is equal to the two diagonals multiplied minus the other two diagonals multiplied. So 12 minus 2x squared. In other words, AD take BC, where it's ABCD. So these two times minus these two times. The inverse is 1 over the determinant, followed by where you swap these two in the original matrix. Here, it's where you swap these two to give D and A, and you put a minus with these two to give minus C and minus B. So if you do that with the B matrix, you'll get this. So that's 1 over determinant times by that rearranged matrix. That's the inverse. So for what values does the inverse not exist? It's when that there is 0, because you could never divide by 0. So when that's 0, factorise it, FOIL it, and so it's when x is those numbers, then you wouldn't have a inverse. This is a contextual question, so we got t-shirts, shorts and jackets made of fabric, thread, ribbing and labour, and the cost of each is there. Now, first question says put M as the materials matrix and C as the cost matrix. So the materials matrix is here. That's a 3 by 4, and the cost matrix is here. Now we've got to write it in that particular order because this is a 3 by 4, and when we multiply by this, which is a 4 by 1, the two inside orders can only cancel when they're the same number, so it has to be in that order so that the 4's cancel, and so the resultant is a 3 by 1. Also look at the when you multiply, make sure it makes sense. So if you look here, it's fabric, thread, ribbing, labour. So fabric, thread, ribbing, labour. When you multiply a row by a column, this is the price for fabric, thread, ribbing, labour. So that makes sense when we're multiplying that row by that column, the corresponding quantities are making sense. Solve the So calculate the costs, you just multiply those out and you get the cost for t-shirt, short and jacket. 3, we need to intersect these two lines, equation 1, equation 2. Using algebra, we will write these as matrix first. So there's the coefficients, 3 minus 4, 5, 2. Multiply by xy is the 2 and minus 1. Because when you multiply these, it is row times column, so that's 3 times x, take 4 times y equals 2. That's equation 1. Likewise, you do the second one, times that equals minus 1. Now if we call that matrix A, that matrix X and that matrix B, and we want to find X, we need to get A over the other side by pre-multiplying it on both sides. This is the identity. Identity times anything is the same thing. And so it's A minus 1B. You've got to pre-multiply by the inverse. So work out the inverse, pre-multiply it, and you get your answer for X. So X equals 0 and Y equals minus a half. That's the intersection point. Doing row operations method, you put the coefficients and the final numbers here. The line represents the X, so that's really your Y. That's the same thing, but this time we use row operations. So first we need to get that to be 0. So we do 5 times the row 1, take 3 times row 2, that'll be 15, take 15. So you do that for everything. 5 times row 1, take 3 times row 2, 5 times row 1, take 3 times row 2. Will give you these 3 new values here. Now the next step is to just simplify this by shrinking that down. Just let's divide by 13 or times by a 13th, and so that takes them down to smaller numbers. Now what we want to do is get this one to be 0. So what we need to do is row 1 minus 2 lots of row 2. So row 1 take 2 lots of row 2 for each of these, and you'll get this new row. Now we want to get this one to 1, so we're going to divide by 3 right through, and so that's now 1. And also we want to get this to 1, so divide through by minus 2. Now we've got the identity, so really the way you read that is the identity times by x equals this matrix here. Now the identity times x is just x. In other words, whatever's sitting here is your x, and x is x and y. So really x is the 0, y is the minus a half, and so we're getting the same answer. This is using matrix algebra. So we need to get x by itself. To get rid of p, we pre-multiply by p minus 1 on both sides. This gives the identity, and therefore x. This has to get multiplied into the bracket, pre-multiplying both of these into there, and then simplify. This next one we're going to post-multiply by x minus 1. And the reason we do that is so that we can reduce this high power that we've got here. We've got an x squared. We've got x sitting in all places, so if we times by x minus 1, we'll get rid of these x's and also reduce the power of the x squared. So here we're post-multiplying, and here we're post-multiplying. Now that has to be post-multiplied in both of those terms, and so we get the identity appearing in these places. And now we've only got one x sitting here, and so we just take the p over the other side, minus 4p, minus p. Likewise, this one here, we're also going to post-multiply by the inverse, and so we get our identities appearing here. Then we need to get rid of the p, so we're going to pre-multiply by p minus 1, and that gets that as an identity, and we've got p minus 1 over here, and so now we just have to
plus I of the other side. Question 5 is a transition matrix. So this is from this month to this month. People transfer from health clubs. So explain the meaning of the 10%, this one here. That means that in a month's time, 10% of Club A members will actually become no club members. Part B, that's all the percentages written down. Percentages from there are written as a matrix. We have to write down the January population matrix. So they give us the January population. Here they have the A membership is 30,000, B membership is 20,000. So there's 30,000, 20,000. That's the A membership. The B membership, that means the no club membership has to be the remaining, because they all got to add up to 90,000, because there's 90,000 total there. So that means all those three add up to 90,000. That's at January. Now if we multiply by the transition matrix, we'll get the population in the next month in February. So we have to work out whether we pre or post. We're going to have to post multiply by the transition matrix, because you can see that the way we've written this is the no club, A club, B club. So when you multiply this row by this column, you can see the no club will multiply by the no, the A by the A, the B by the B. So it makes sense to set up in that fashion. Also the order works out. So this is row by column, so that's 1 by 3. And this is a 3 by 3, and those middle numbers cross out, and so the answers are 1 by 3. So if we multiply that, we'll get the population in February. So these are the new populations. How many would be in each club in March? So we have to do it again. We could either do the original times by t, or we could get we could do the this one here, the February, and we could just times that by t, or we could get the original January and times by t squared. That'll take from January to February, 2 months worth. Question 6 is the coding question, similar to your assignment. So we're starting off with E 3 2 10 7, and we have the message M, and we get our final coded message over here as EM, and we have to work out what M is, the original message. So to do that, we actually pre-multiply by E minus 1 on both sides, and so that's the identity, so that means M is equal to this. So we got to find E minus 1, so it's 1 over determinant, and you swap the diagonals and put negative with the other diagonals, and so you've got the E minus 1 there. That's this one, and now we have to multiply by EM. So the question was work out the decoder matrix, and the decoder matrix simply is your E minus 1, so that's your answer there as the decoder matrix. We're going to have to actually pre-multiply that by the coded message to get our original message. And not asking for the original message, just the decoder matrix. And question 7 is now using translations, rotations and reflections, and you're given those matrices down here. So in general rotation, if you multiply this matrix by coordinates, these coordinates, you'll rotate them by angle theta. If you pre-multiply it by this matrix, you will reflect it in the line y equals tan theta x, and this is how you translate something, move something. Okay, so we have x plus y equals 5. We want to translate it, so it's going to be xy plus your translation vector, and so your new value is going to be your old value plus this, but we want to know what the old value is so that we can actually substitute it into this equation. So rearranged, this is the old value in terms of the new values. Plug that into x plus y equals 5. So your x is equal to this, and your y is equal to this. So you plug those into the x and the y values, and so we get our new function. So this is being translated, and this is your new function. When you rotate, you use the matrix that's given down the bottom, and if you do the cos 30, sin 30, etc., and put it in the matrix, here, this is your matrix here. Now your new value is x dash y dash in terms of old x y's is given by this. So we want to find once again the old x y, so we can substitute it back into this equation, x plus y equals 5. So to get the old x values we need to pre-multiply by the inverse. Here's the inverse over here. Pre-multiplied, we get our old x and y values, and we plug them into the x plus y equals 5 formula, and so we get our new equation. So this is now being reflected, rotated. Now we're going to do the reflection in the line y equals 2x. Now the line y equals 2x has a slope of 2, and that's also equal to tan theta. Now you could work out what theta is and plug it into the formula here for a reflection. Alternatively, you could use the other formula, and I'll have this in the test, where instead of using these in terms of thetas, you could do it in terms of m's, where cos 2 theta is equal to 1 minus m squared on 1 plus m squared, and sin 2 theta is 2m over 1 plus m squared. So that means that this one is also the same, and this one here is the negative of that one on the top left. So that is the equivalent matrix to this one here. So you can use it in terms of slopes m rather than in terms of angles theta. Now if you do that, you'll get this matrix here, and you can now get the inverse, and so now we can get x, the old x values in terms of the new x values, and once again plug it into your x, y plus y equals 5, and you've got your new equation.